Hey, this is Robert. So typically when I grade your homework, I'll do it kind of on an individual basis, and I'll give you feedback right on your paper. But this chapter tends to be one of the more difficult ones, along with the relativity chapter. And I noticed a lot of people, even the ones that got the answers right, they said they weren't really all that comfortable with the equations and things like that, which I completely understand, and don't get too worried if this chapter was really hard for you. Because like I said, it's one of the more difficult ones. But I thought instead of, giving you text or letting you look at answers on a piece of paper, I'd actually walk you through how to solve the problems. So then you can use this to study for the quiz and hopefully get a really good grade, because I want all of you to succeed and do well. So I'm just going to split this into like 3 videos. The first video I'll cover the first 2 problems. The second video I'll cover the next 3 problems. And then the fourth video will be kind of or the third video, will be a quick little intro into the 3 equations and when to use them, because that seemed to be a pretty big problem for people. And if you have questions after you look at this, you can of course ask me if you're still confused on something. So the first problem was number 38, and it said, the sun has a profound influence on the Earth's motion. Does Earth influence the sun's motion? Explain. So first I want to kind of explain something, because I saw 4 or 5 people kind of say something that was actually incorrect. So here's a very simplistic view of the sun and the Earth orbiting around the sun. And so there seemed to be, like I said, 4 or 5 people that were under the impression that the sun is stationary, just kind of spinning right there, and then the Earth is rotating around the sun. This actually isn't what happens. The sun is on the edge of one of the arms of the galaxy, the Milky Way galaxy. So let's just call this point over here the center of the galaxy, right? So the sun is orbiting around the center of the galaxy while the Earth is rotating around the sun, okay? So the sun is just a star. It's actually just an average sized star. And all stars and things rotate around a galaxy or some central core of a galaxy. And then the galaxy itself is not stationary, it's also moving. So there's no really stationary point that you can use that's not moving. And you'll see that when we study relativity, that this comes into play, the fact that there's no stationary reference frame. So I just wanted to mention that, because some people seem to think that the sun just kind of sat there and planets revolved around it. Now in terms of the question, we all obviously know that the Earth orbits the sun because of the gravitational field of the sun. And so the question just wanted to know, does the Earth also impact the sun? And the answer is yes. Now I know some of you put yes, but the Earth is so small that the effect is very, very little. And that's right as well. So I gave you credit if you said something like that. The Earth is much, much smaller than the sun. So the impact that the sun has on the Earth is much greater than the impact that the Earth has on the sun. But it does have an impact, okay? Because Earth is a massive body and it dense space-time, and it also and so there is a impact on the sun's movement. Okay, this is actually one of the ways that we find other planets in other solar systems. So because you have all these planets around the sun or another star, it actually looks to us, you get this wobble type look as it goes about its orbit. And so we can kind of see these wobbles in other stars, and then we can infer the mass of the planets around those stars. And so it definitely has an impact on those stars, and Earth has an impact on the sun. It's just very small. So that was kind of the answer for number 38. Now your next question was number 60. Okay? And let's read it. The gravitational force between 2 very large metal spheres in outer space is 50 newtons. How large would this force be if the mass of each sphere were cut in half? So, when you read force, when you see gravitational force, or it's asking you about force, you should instantly think of this equation. So let's go through what this equation means real quick. F, force, is force. G is just the gravitational constant, so it's just a number. And we always know that number. It's in your textbook, okay? M sub 1 is just the mass of the first object. M sub 2 is just the mass of the second object. And r is the distance between them, or the radius between them. And you square that. That's what the exponent 2 is up there. So the kind of situation looks like this. We have one mass, we have two mass, a second mass, and they're separated by some distance. And so this equation gives us the force between these objects here. Okay? And that's all that we're talking about. So I noticed some people were kind of confused when they saw like N, like 50 N. That N stands for Newton, and it's just a unit for force, like meter or kilogram. And I saw some people were confused by M squared. That's just meters squared, and kg is kilograms. Okay? So those are just units, so don't let those mess you up when you see them tacked on the end of numbers. So this is case 1 here. That's what we started with. Now let's go to case 2. Now they're separated by the same distance, r, okay? But instead of having a mass of m1, it has that mass of half of m1. And this is half of m2, okay? So now it looks like this, right? F is equal to G. Now M1 in this case is 1/2 of M1. And M2, the mass of the second object, is 1/2 of M2. And they're the same distance apart, so it's still r squared. Okay? With multiplication, we can rearrange these terms to give us this. 1/2 times 1/2 times M1 times M2 r squared. Alright? And then we know that 1/2 times 1/2 is 1/4. So you get this. And let me just bring out this 1/4 in front so it's really easy to see for you. Alright? So let's compare case 1 and case 2. Case 1, this was the force. Case 2, this is the force. How are they different? Well, just this 1/4 term here. Alright? So we know that when we cut the mass in half by each one of these, we're going to get 1/4 of the force that it was originally. Okay? And since we know that this original force was 50 newtons, then 1/4 of that would give us 12.5 newtons. 1/4 of 50, which would be 12.5 newtons. And that would be your answer. Alright? And that's all there is to it. So you kind of have to get a little bit used to plugging into equations. And this will be on the quiz, so I'll just warn you, okay? Being able to take this equation here, this F equals G M1 M2 over R, and me asking you things like, if I cut the distance in half, if I triple the distance, if I triple the mass of one but leave the other mass alone, if I cut both masses by 1/4, all of those things, there will probably be 2, I would say, possibly 3, but at least 2 of the 10 questions will be something like that on the quiz. So make sure you understand where all this came from, okay? And that's that. So go ahead and watch the second video if you have questions on the last 3 homeworks. And thank you very much.